In this tutorial, I want to talk about the new adaptive tone mapping technology that's found in HDR Express 2. Before I get started, I want to give a little bit of a fair warning. We're going to get a little technical, showing charts and histograms and whatever to explain this technology. But don't worry, there's not going to be a quiz on it at the end. So there's nothing to be afraid of. This technology is all working automatically for you under the hood when you process your images with HDR Express 2. We're putting out this presentation because I know that there are a lot of people that are interested in how this technology works, and this is one of the key technological differences that sets HDR Express 2 apart from its competitors. So let's get started at the end of the workflow, if you will. This is the final result. It's a fully tone mapped, fully processed HDR image. It's a series of images that I took at Fort Point, just under the Golden Gate Bridge in San Francisco. This is what the 32-bit image looks like after I merged all the images to create my HDR image. Now you may look at this and think, oh, the highlights are blown out, obviously. But this is a 32-bit image being represented on an 8-bit display. It's very important to note that. All of our processing happens on the full 32-bit data inside of HDR Express 2. So if I adjust the brightness display on this image, you can see that I have over 16 stops of exposure. This is the shadow exposure, and you can see that I have all of this fine detail is here and visible in the brickwork. If I then switch over to view the highlight area of the image, you can see that I've captured all of the detail outside this portico of the tower and the sky and the brickwork in the distance. So the trick is to be able to balance this with tone mapping in an HDR process, and that's what we do with HDR Express 2. So in order to explain how we get there, I want to start off talking about the histogram. You can tell a lot of information about your image by viewing the histogram. And HDR Express 2 shows you a true 32-bit histogram, where you can see how the histogram shape changes as you process and modify your image. So if you look at this image, this peak represents the shadow areas of the image. So all of that data that was inside the structure, all the brickwork and everything is indicated up here. There's another peak out here that represents the highlight information. So this corresponds with all of the detail that's out here in the fully lit brickwork and the tower and the sky in this scene. The traditional tone mapping process requires that you adjust the brightness and the highlights and compress the contrast of the image in order to make it fit into a smaller range that can be displayed on your computer screen. We call this the display zone. This is typically a range of about 8 stops that can be shown on your normal computer displays. The 0 EV is your white point. This is the brightest part of the image that can be displayed on your computer screen. So anything above 0 EV is blown out and cannot be displayed on the screen, even though that data technically is still in the file and can be adjusted and recovered back into the display range. Now this is the first pass of the tone mapping, and you'll notice that we sort of have a mid-tone value of about -4 EV. The next step we want to do is adjust the mid-tone brightness and shift that up using a curve like this. And what we'll do is we'll shift it up to about -3 EV, which will be our new mid-tone value. So this is what we had before, and this is what we have after. Now simply compressing the highlight range in the image can produce some unwanted results. Let's take a look at what the effect that this curve has on this particular image that we were working with. You notice now that we have a nice brightness and detail here in the shadow range. Now let's zoom in on the highlight areas of this image. So if you look out here, you can see that we have lost contrast and the colors are kind of washed out. In fact, it's very difficult to make out any of the detail in the brickwork out here in the exterior highlight area of the image. Now, one way that I can fix this is to expose for the highlights. So I can adjust the brightness in HDR Express 2 to basically darken the image in order to maintain the contrast and the color, the brightness and the saturation outside in the highlight area as I want. But the effect of that is that I end up darkening the whole scene too much, and I really want to have some more detail in the shadow areas of this scene. So the best way to approach this is with a new tone mapping scheme called adaptive tone mapping. Here we see the same histogram that we started off with from the original image. Now with adaptive tone mapping, we're using a customized nonlinear function in order to optimize both the shadow and the highlight detail in the image. Let me superimpose this curve on the original histogram. So now if I add a linear curve just as a reference to this diagram, the red line here, you can see how the areas in the shadows where the contrast is being enhanced, but not quite as steep as we enhance it for the highlight areas. So with adaptive tone mapping, we're able to much better balance the needs of both the shadows and the highlight areas in the same image in order to get the maximum contrast and color fidelity out of both of them. So once I apply this tone curve to the image, I end up with this tone mapped histogram. And you can see now how the histogram shape is much wider, and I capture a lot more of that highlight contrast and detail that I wanted. Let's compare it to the previous method. So this was the previous method, and you can see we have an area here. This was our shadow area, and this is where our highlight information was compressed to. Now with the adaptive tone mapping, you can see a much more even histogram, and this produces better results. So this is how the two methods look mathematically, but let's take a look and see how it really matters with a real image. And that's, of course, the most important thing. This is the default result of the automatic tone mapping with the previous method. Now, this is the default result after the adaptive tone mapping. Again, this is what the software does for you automatically. This is the result that you get after you've merged the image, and it's the way it's displayed to you initially before you do any processing or fine-tuning to the image. This is your default starting point with the adaptive tone mapping function. Let's zoom in and look at this critical area in the highlights again. This is with the previous method, and this is with the new adaptive tone mapping method. And you can see now that without having to do any manual adjustments at all, we're able to really capture the highlight detail, the contrast, and the color of the highlight areas while also maintaining the shadow information the way we want. Now this again is the final processed image. So I did a couple little tweaks here, a little bit of work with the contrast, added a little bit more black point, and made a couple of minor adjustments. But this is my final result. And this is HDR Express 2 with the automatic adaptive tone mapping algorithms. So I hope that this tutorial helps to illustrate the differences that our new adaptive tone mapping technology in the Beyond RGB color space makes for high contrast HDR scenes.